In this section, we're going to talk about how we can use Prometheus to monitor an application running on a Kubernetes-based environment. And we're going to cover two things. We're not only going to cover how we can monitor the application that's running on a Kubernetes cluster, we're also going to learn how we can monitor the cluster itself, because there's going to be a lot of metrics that are available when it comes to monitoring the underlying infrastructure of your Kubernetes cluster. In the previous sections of this course, we covered how to set up a Prometheus server so that we can monitor various applications. And we can easily set that same server up to monitor a Kubernetes cluster. However, instead of having the Prometheus instance running on a separate server, it's actually better to set up and install the Prometheus instance on the Kubernetes cluster itself. And there's a couple of benefits to this. First of all, the main thing is you want to deploy your Prometheus server as close to your targets as possible. So if your targets are going to be applications running on a Kubernetes cluster, it's better to have the Prometheus server running as close to that as possible on the cluster itself. And in addition to that, we can make use of pre-existing Kubernetes infrastructure. So we don't need a separate server. We don't need a separate VM to host the Prometheus server. We can just run it on our underlying Kubernetes infrastructure. Now, like I mentioned, there are two things that we can monitor when it comes to Kubernetes. We can monitor our specific applications running on the Kubernetes cluster. And so that could be potentially things like a web application or a web server, or really any application that you have running in your environment. But we can also use it to monitor a Kubernetes cluster in itself. And there's a couple of things that we would want to monitor. First of all, we would want to monitor the various control plane components. So things like the API server, the kube scheduler, the core DNS. We'd also want to monitor the kubelet process, which is basically the equivalent of like cAdvisor. So that's going to expose container level metrics. Then there's also kube state metrics. So this is going to give us cluster level metrics. So things about like metrics on deployments, pods, and various Kubernetes objects or constructs. And finally, we'll also want to have a node exporter running on all of our nodes, because on a Kubernetes environment, a node is nothing more than just some Linux server. And like any other Linux server that we've covered in our course so far, a node exporter is going to expose metrics about that server instance, because we do want to monitor the nodes themselves. Now, by default, we are unable to collect cluster level metrics like pods or deployments or services or things of that nature. Kubernetes just doesn't by default expose those metrics. And so to get access to those metrics, we have to install the kube state metrics container into our Kubernetes environment. And that container is going to then be responsible for then advertising those metrics or making it available for our Prometheus server. So just something to keep in mind, you will have to deploy a container to actually get access to that information. Now, every host should run a node exporter so that it can expose CPU, memory, and network related stats. And there's going to be a couple of ways of doing this. We can manually go in and install a node exporter on every node, or we could even go in and customize the base image of our node so it contains the node exporter process. But I think the better option is, since we are making use of Kubernetes, we can actually use a built-in concept called a Kubernetes daemon set. And so a Kubernetes daemon set just makes sure that a pod will run on every single node in the cluster. And so we could set up a pod that contains the node exporter process and have it automatically run on every single node in our cluster automatically, so that it's already running a node exporter process. And that way, if we add in a new node, we don't have to remember to install the node exporter process. Kubernetes daemon set will automatically assign a pod to that node that's going to contain the node exporter process. Now, with Kubernetes, we're going to be making use of service discovery. So we will access the Kubernetes API to discover a list of all of the targets that we need to scrape. And that's specifically going to be all of the Kubernetes-based components, all of the different node exporters that we have installed, as well as the kube state metrics. These will all automatically be discovered by service discovery so that you don't have to manually go in and enter the endpoint addresses for each one of those. To deploy Prometheus, we can manually go in and create all of the necessary Kubernetes objects. So that's going to be all of the various deployments, services, config maps, and secrets, so that we can get everything necessary for a Prometheus instance to work on a Kubernetes cluster. But this is fairly complex and it requires a lot of configuration out the bat, and it's not exactly the easiest solution. And instead, another thing that we can do is we can actually deploy Prometheus using a Helm chart to deploy the Prometheus operator. And that way, we can make use of Helm to actually deploy all of the different components of a Prometheus solution onto our Kubernetes cluster. So, what is Helm? Helm is a package manager for Kubernetes. And what that really means is that all application and Kubernetes configs necessary for a specific application can all be bundled into a package and easily deployed by making use of Helm. And so all of the deployments, all of the services, all of the secrets, all of the Kubernetes configs that you need for your application to run, you could just bundle it up, and then all you have to do is then just run Helm install, and it's going to install all of those necessary components to get your application up and running. Now, I want to quickly discuss a concept called Helm charts. A Helm chart is a collection of template and YAML files that convert into Kubernetes manifest files. So what that means is when I say that Helm is a tool that we use to package our application, what it really means is that it's a tool that's just going to contain all of the necessary configs that we need to deploy onto our Kubernetes cluster. So this chart or this package is going to have all of the Kubernetes configs, as well as application-specific configs. It's going to keep them all in YAML files, and then it's going to also have some templating functionality so that when we deploy our application, we can customize the deployment so that if you want to tweak certain settings, you can do that by using the templating engine. So that's all a Helm chart is. It's just the ability to package your application. So each application will have its own chart. And the great part about Helm charts is that they can be shared with others by uploading a chart to a repository. So just like you upload your application code to some, like GitHub or GitLab, and then anybody else can pull your code if they'd like, you could do the same thing for Helm charts by using a Helm repository or a chart repository. And this is going to be the specific chart that we use. And what this chart is it's called the Cube Prometheus stack, and it comes from the Prometheus-community repository. But this chart's great because it deploys everything that we need to get Prometheus up and running on a Kubernetes cluster. And it's also going to deploy Alert Manager automatically for us, as well as the push gateway. So it's really just deploying everything for us with just a simple click of a button. And it's going to also deploy a Prometheus operator. So as I mentioned, the Cube Prometheus stack chart makes use of the Prometheus operator. And I want to quickly discuss what is an operator when it comes to Kubernetes. So a Kubernetes operator is an application-specific controller that extends the K8s API to create, configure, and manage instances of complex applications, like Prometheus. So it's going to manage the entire lifecycle of your application. It's going to handle the initialization, the configuration, and the customization of any of your applications, like Prometheus in this case. So it will actually help install Prometheus, and then it will manage Prometheus as Prometheus is up and running in our environment. It's going to do a lot of convenient things for us, like automatically restarting it whenever we make config changes to our Prometheus configuration, and it's going to provide a lot of other helpful abilities when it comes to managing our Prometheus instance. And if you want to read up on this operator, you can go to this link below. So the Helm chart is actually going to make use of this specific operator. Keep in mind, you can actually run this independently outside of a Helm chart if you wanted to. So if you just wanted to play around with it and get a little bit more familiar, you can do that as well. So with this Prometheus operator, we get access to a couple of custom resources that help aid in the deployment and management of a Prometheus instance. And so you'll see that when we go to customize our Prometheus server, we get a high-level abstraction over the standard Kubernetes API. So instead of creating a deployment or a stateful set or any of the basic Kubernetes objects, we don't have to worry about that. Instead, it comes with a built-in Prometheus resource. So we could just create it like any other Kubernetes object, but just call it Prometheus, and then we can customize it through that using the API for that resource. And it comes with several other custom resources that all act as an abstraction over the standard Kubernetes API that allow us to manage the other aspects of a Prometheus installation. So we've got one for Alert Manager. That's going to be for configuring and deploying an Alert Manager. We have one for Prometheus rules. We have one for the config for an Alert Manager. And then we also have Service Monitor and Pod Monitor. Those are just resources that we use to tell Kubernetes about other endpoints that we want to scrape. And so with this operator, you're going to see that it's going to make life a lot easier when it comes to working with Prometheus, because we have access to these high-level abstractions that will make it a lot simpler to modify and manage your Prometheus instance. Okay, so in this video, we're going to go over installing Helm and getting our Helm chart deployed so that we can get Prometheus set up and installed. And so the first thing that we're going to do is we'll go to the documentation page for Helm, and it's going to give you all the instructions that you need to get Helm installed, and it's going to go over the different steps for the different operating systems. But for a standard Linux machine, they have a built-in script where you could just run this following curl command. It's going to download the script. And all we have to do is just change the permission so we can make it an executable, and then run the executable, and it's going to install Helm automatically for you. Once you've got Helm installed, you'll want to first add the Prometheus community repo, which you can do with this following command. And after you add the repo, you'll want to update it. And now we can go ahead and install our chart. So we can run helm install Prometheus and then the name of the specific chart, which is going to be the name of the repo / and then cube-prometheus-stack. And this name Prometheus here, this is the release name, so you can technically call this whatever you want. I just called it Prometheus. So if you go to the installing Helm section in the Helm documentation, this is going to walk you through the different methods for installing Helm onto your machine. Down below, you can see how you can install it through package managers. So they've got it for Homebrew if you're running Mac, Chocolatey for Windows, as well as apt for Ubuntu, and a few other options as well. I'm just going to use their default installer script that's going to automatically detect my operating system. Especially if you're running on a Linux machine, it'll just be fairly straightforward. You just copy the script and it's going to do all the work for you. So I prefer this method, and that's what I recommend, but you can use any one of the methods that they have documented on this page. And so now it's just a matter of copying in those commands and then just pasting it into our terminal. So I got the first command right here. That's going to download the script. So if I do an ls, we could see the get helm.sh. Then we want to do a chmod 700 get_helm.sh. And that's going to make it executable. And then I can just do a /get helm. And after it's installed, we can verify that it was successfully installed by doing a Helm version. This is going to tell you what version you have installed, and if it returns an output like this, that means it was successfully installed. Okay, so we've gone over all of the instructions necessary to add the repo and then be able to actually install the chart on our cluster. But if you want to see these instructions laid out, you can also take a look at the documentation for this specific Helm chart, and I provided a link for this inside the slides. And so down here, you could see these are the steps that you have to run to get the Helm repository added. And then this is the command you need to run to get the Helm chart installed on your cluster. So let's go ahead and run those. So I'm going to get the Helm repo added, and that's going to be the command. And you can see that I already have this Helm repo added, so it just says it's skipping the instructions. You'll see a different output, but that's just because I've already run this command. Then we'll want to do a Helm repo update. And once that's complete, we can then go ahead and install the chart. And to do that, all we have to do is a helm install. Give it a release name. You can call this anything you want. I just call it Prometheus. And then we do Prometheus -community /cube Prometheus stack. So that's going to install this specific chart onto our Kubernetes cluster. Now, before we do that, when it comes to deploying this chart, all charts allow you to customize it. And there's different values that you can customize, which will tweak how Prometheus is deployed. And if you want to see the different options that you have, what we can do is we can run the following command. We can do helm show values. And then we provide the name of the specific chart. And this is going to show us the different values that we can customize. So if you run this, it's going to print it out, and there's going to be a lot. So what I recommend you do is run this following command and then pipe the output to a file, and we can just call this values.yaml. And that's going to create a file that we can take a look at. And so this is going to contain all of the customization that we can do. So you could see, what namespace you want to add the Prometheus chart to. And there's pages and pages worth of configuration. So it's documented fairly well. So you could just go through it, read what each specific configuration option does, and then just tweak it to however you like it. For now, we're just going to do a default deployment with the standard default configs. I think the defaults are fairly fine. Later on in this section, I will show you how we can tweak these so that we can modify the configuration. And if you want to deploy using the customized value, so like if you went in and changed one of the values in this file, then we'd have to change the command. And instead of doing a helm install, then the release name and then the whatever the chart name is, we would then just make sure to pass in the daf value and then the name of the file that has the customization. So that's going to be values.yaml. So that's the only change that you have to make. But we're going to use the default, so I'm just going to do helm install Prometheus and then the name of the specific chart, and we'll let that run. Okay, so after a little bit, it's going to complete, and in the next lecture, we will go over everything that this chart deployed, all of the different Kubernetes resources that it created, and I'll explain everything that this specific chart has actually configured for us out of the gate. Okay, so we got our Helm chart installed. Let's take a look at what it actually created. So I'm going to do a kubectl get all. This is going to show all of our Kubernetes resources. And there's a couple of things I want to point out. We're going to start off at the bottom, and we're going to start off at the stateful set. So there's two stateful sets are created for us. And if you take a look at this one with the very long name, so it's going to give these long names. This is our Prometheus server. So this is our Prometheus instance, and this is going to be the container that's actually running the process. But when we connect to our Prometheus server, we're connecting to this container here. And then above that, we have another stateful set for Alert Manager, and this is going to be the Alert Manager instance. Now, there's a couple of other things I want to point out, and I want to go to the deployments. So there's a couple of different deployments. We've got this Prometheus Grafana. So we haven't really covered Grafana in this course, but that's just a graphical UI tool that you can use to visualize the data that you have within your Prometheus time series database. And so this Helm chart will actually go ahead and install Grafana automatically for you so that you can have it up and running and connected to your Prometheus server very easily. We're not going to focus too much on that for this course because this course is just focused on Prometheus, but just know that your Helm chart actually does configure it for you. Now, the next thing is the kube Prometheus operator. So this is the operator that I said that's going to manage the lifecycle of our Prometheus instance. It's going to handle, updating the configs and restarting the process anytime the configs change and a few other things. You don't really have to worry too much about what it does. Just know that this is the container that's responsible for managing that. And then you have kube state metrics. As I mentioned, when it comes to Kubernetes object metrics, so things like metrics about deployments, services, pods, all of those specific metrics, like I said, you need to have a container running to actually get that data and then expose it. That's what this specific deployment is for. And then, replica sets, that's just a subset of a deployment. So you have one for the Grafana server, one for the Prometheus operator, and then one for the kube state metrics. Now, above the deployment section, we have one daemon set getting created, and it's called Node Exporter. So this daemon set is responsible for deploying a node exporter pod on every single node in our cluster. And so that's exactly what a daemon set does, is it just takes a pod and it's going to make sure that every node, even if you add a new node to the cluster, it will have this specific pod deployed on it. And this pod is responsible for collecting host metrics, so things like CPU utilization, memory utilization, information about the file system, and it will expose that endpoint so that our Prometheus server can track metrics regarding the node itself. And we can see that there's two ready in an up state. And the reason for that is if I do a kubectl get nodes, right, we're going to see that we have two nodes. And so that's why we see that. Now, there's two things that I want to just quickly go over before we wrap up this kind of high-level overview of all the things that have been installed. If we take a look at the pod section, these are going to be all of the pods that have been deployed. So we have our Prometheus server. So this is going to be the pod that contains our Prometheus instance. We've got our alert manager up here. Then we have our Grafana, and then our Prometheus operator, our kube state metrics pod. And then we have two node exporters. So that's going to be one running on each one of our cluster nodes. And then in the service section, we're just going to have their respective services for all those pods. And just to point out something real quick. All of these are cluster IPs, so right now nothing is kind of exposed to the public. So when we want to be able to access the Prometheus server or the Grafana instance, we're going to have to set up either an ingress or modify one of these services to be a load balancer, or we could just set up a proxy so that we could just kind of quickly play around with it, but just something to keep in mind. Now I'm going to just quickly do a kubectl get stateful set. And what I want to do is I want to just do a describe on this Prometheus server so that we can take a look at the configurations that the Helm chart provided for this specific Prometheus server. So I'll just do a kubectl describe stateful set and then paste that name in. And there's a lot of output. It can be a little bit hard to read. So what I'm going to do is I'm going to run the same command, but I'm going to pipe it to a file so we can let VS Code do all of the syntax highlighting. So it's a little bit easier to read. So I'm just going to call this prometheus.yaml. And I'm going to open this file up, and we'll take a look at it real quick. And so there's a lot of base configuration, but what I want to do is I want to take a look at the containers. So you can see here we have one init container, and this is going to be an init config reloader. So this looks like it's responsible for creating the initial configuration for Prometheus, and you can see that it's using a special Prometheus config reloader image. And you can take a look at the different arguments, but what I'm more interested in is I want to take a look at the Prometheus container itself. So here under the container section, we can take a look and see that we have the Prometheus right here, and we can see that it's using this specific image. And we can take a look at the different arguments it has. So these are just the standard arguments. Here we're passing in a config file. We've got the path for the time series database, and we also have the path for the console and console libraries. And if we scroll down a little bit further, we have another container that's running called config reloader. So this is going to keep track of any changes that are made to the configs, and it's going to be responsible for reloading the Prometheus instance so that it can update its configuration. And what we can also do is if you go to the mounts, you could take a look at where all of the configs are actually configured within Kubernetes. So under mounts, you see that /etc/prometheus/config. So this is going to be that prometheus.yaml file. This is coming from config. And so if we take a look at the volumes, we have a volume called config. And we can see that this comes from a secret, and this is the secret name. And we also have this /etc/prometheus/rules. So this is going to be the rule files, or the list of the rules that Prometheus is going to have. And this comes from a config map, where if we take a look at this name, we can see that that comes from right here. And this is going to come from a config map called this. And so we could just describe that those secrets and config maps to get a little bit more information on how everything's set up. So I'm going to grab this secret right here, just so we can take a look. And I'll do a kubectl describe secret. And we can see that we have a secret right here with the prometheus.yaml.gz file here. So this is going to be what contains our Prometheus configuration. And I'm sure you're wondering, well, how exactly do we modify this? Where do we modify it? And you'll see that when we're working with the Prometheus operator, it's set up a very nice way to actually be able to modify the Prometheus config. So we don't actually have to touch this YAML file. We can actually use regular Kubernetes manifests to actually generate Prometheus configurations. And when we get to that section, you'll see just how easy it is. So you don't really have to worry about this at all. And if we just want to quickly grab the name of the config map for the rules file, I'm going to just grab this one right here. And I can do a kubectl get or describe config map. Paste that in. Okay, so this looks like it actually stores the rule file itself. And what I'm going to do is I'm going to pipe this to a file, and I'll call this rule file.yaml. And we'll take a look at this. And we can see that we have the file name, and then we can see that this just looks like a standard rule file, and there's nothing else to this one. In this case, it's just a standard config. And you'll see that also when it comes to modifying the rule files, the Prometheus operator gives us some high level abstractions to be able to manipulate the rule file instead of us going in and manually updating this ourselves. And I want to take a quick look at the operator configs. So if I do a kubectl get deployment, let's just take a look at what this deployment actually looks like. So I'll do kubectl describe deployment, and we'll grab the operator, and then I'll pipe this to a file as well. And we'll open that up and we'll just take a look. So this is going to be just a standard deployment. And if we go under containers, we can see that we have this container called kube-prometheus stack, and it's going to be using the Prometheus operator image. And it's got a couple of arguments that we've had that it automatically provided us to get it up and running and configured properly. But outside of that, there's no other configs actually specifically needed for the operator. There's only one mount, which is just the TLS certificate. But outside of that, no other mounts. So the operator is pretty straightforward. You don't really need to know too much about how it truly works. You just have to understand that it's the one that's kind of responsible for managing your Prometheus server and managing the configurations. So how exactly do we connect to the Prometheus server? How do we access the UI? Well, there's a couple of different ways of doing this. If we do a kubectl get service, we can see that we have the Prometheus service running here, right here. So this is going to provide that connectivity to the actual Prometheus instance. And what we want to do is there's a couple of different options. Right now, we can see that it is a cluster IP type service, which means that we do not have access to it from outside of the cluster, only within the cluster. And if I do a kubectl get, and then we'll get this service specifically, and I'm just going to pipe this to a file just so we can take a look at it. If I grab the service, and we can see that from the type section down here, we can see it's set to cluster IP. So you could just go ahead and update this and use one of the other different services like a node port or a load balancer so that you can access the Prometheus server from outside the cluster. Or if you wanted to, you could also set up an ingress and route the traffic for a specific URL or domain to this specific service, and that's going to allow you to have outside connectivity to the Prometheus server. And so whichever method you want, just go ahead and choose your preferred method. But for the sake of this demo, I'm just going to do port forwarding so that we can just take a look and just verify that everything is in fact running properly. And we can do that pretty easily. So we have the service, and I'm going to do a kubectl get pod. And so now what we do is we do kubectl port dash forward, and then we grab the specific pod and then the port that we want to connect to. And so if you take a look at the Prometheus service, we could see that it's listing on port 9090, so just pass in port 9090. And so traffic destined to your local host on port 9090 is going to get routed to your Prometheus server. So if we go to this specific address in our browser, we should be able to route to our Prometheus server. And you can see that we do, in fact, have access to our Prometheus server now. But like I said, this isn't meant for as a long-term solution. So if you need connectivity from outside the cluster, you're going to have to either update the service to be either node port or load balancer, or set up an ingress to route traffic to that specific service that we have for the Prometheus server. Okay, so what I want to do now is, now that we can connect to our Prometheus server, I want to take a look at the configs that were installed by default. And before we do that, I want to just quickly go over the Kubernetes service discovery functionality, because Kubernetes does, in fact, have service discovery as well. So we're able to dynamically learn the different targets that we want to scrape. But there's a couple of different options that we have when it comes to service discovery. And if we take a look at the Prometheus configs, you can see that for one, we have node. So for the node service discovery, this is going to discover all nodes within a Kubernetes cluster. And then it'll also show you all of the meta labels that come with it. We can also discover all of the services and their respective ports. We can take a look at the pod service discovery, which is going to discover all pods as well. But at the end, we've got this endpoint service discovery. So this says that the endpoints role discovers targets from listed endpoints of a service. And so this is probably the most flexible of the service discovery. We can basically discover pods, services, nodes, and everything else using the endpoints because everything is going to have an endpoint or a service assigned to it. And so really just think of an endpoint as just an IP address and a port tied to some resource. It doesn't matter what that resource is. It could be a pod, a service, it could be a node, it could be really anything. So everything technically has an endpoint. And so what we can do with the endpoints is we can just get everything. We can get all of the pods, we can get all of the nodes, we can get all of the services, we can get everything in our cluster. And then we can set up filters so that we can only scrape targets that match certain labels. So that's how we're going to be able to get a list of all the nodes, get a list of all the services using the endpoints service discovery. And I wanted to point this out because in the configs, the default configs exclusively use endpoints, so I don't want you guys to be kind of confused by that. The endpoints endpoint gives you access to everything, so it's the most flexible one. Okay, so with the Prometheus server up, or the web UI up, let's go to status and configuration, and we can take a look at the configs that were automatically generated. And let's ignore the global config. I mean, we're already familiar with that. Instead, I want to focus on the scrape config. So everything else doesn't really matter too much. Let's just go down to the scrape configs. And so here we've got a job name, and so we can see it says Service Monitor, Default, Prometheus Cube, Prometheus Alert Manager. So this is the scrape config for scraping the Alert Manager. And you'll see there's a whole bunch of configs, and I want to start off actually at the bottom of the config, where we can go to the Kubernetes service discovery. And you can see here we use the role endpoints that I mentioned. And that's all we have to do. So this is going to get all of the endpoints in our Kubernetes cluster. We don't really have to worry about anything else here. And the way we're able to get specifically the alert manager target and not accidentally scrape other things is that if you take a look at the relabel configs, you could see all of the labels that we're going to actually keep and scrape. And specifically, if you go to this line right here, this is going to look for this specific label, Meta on Kubernetes Service Label App, and then also Meta Kubernetes Service Label Present App. And then we have a regex that's going to match Kube Prometheus Stack Alert Manager. So this is what's going to allow us to figure out which endpoint is meant for our alert manager. And we can see that we have a keep here. So we're going to keep this. So we're going to scrape this alert manager instance. And then we've got several other ones. At the top here, we can see that we have the source label. And here we're going to change the target label to be temp Prometheus app. So this is just relabeling it as a temp for, I'm not exactly sure why they're specifically doing this, but I just want to quickly just go over all of the other configs. So here we've got Meta Kubernetes Service Label Release and Meta Kubernetes Service Label Present Release. And we can see that it's set to Prometheus and true. And so the action is keep. So this is that label that we kind of, we'll discuss this in a bit, but basically everything that Prometheus should be scraping and monitoring, there's going to be this label that we expect called Prometheus, and that's going to determine if we should be scraping it or not. And so that's why we're keeping that. And it's just going to go through all of the different labels of all of our various endpoints and just figure out which ones represent the alert manager. And that's going to be all of these rules here. And if we keep going down below that, we've got the Kubernetes API server. So this is going to scrape the API server itself. And this is going to have the same exact SD configs. And then it's going to have a bunch of relabel configs so that we can match on just the API endpoint, and we can collect those metrics, and then we'll collect those targets and metrics, and then we'll drop everything else. And if we keep going down, we've got the one for core DNS. It's still, once again, no different than the other ones. It's just a matter of getting the labels to match so that we can grab the core DNS endpoint. And let's see what else we got. We got the Kube Controller Manager. We've got Kube etcd, Kube Proxy. And so it's just going to keep going down the list of all of the various different endpoints that we want to scrape. And if we actually just go up, we can take a look at the service discovery, and we can see everything that it's discovered. So we've got our alert manager. We've got kubelet 0, kubelet 1, kubelet 2. We've got our operator, our Prometheus server, kubestate metrics, our node exporter, API server, and core DNS. And if we go to targets, we should be able to see that all of them are in an upstate and we're able to scrape them successfully. So all of this was set up out of the gate for us using the Helm chart. So we didn't have to manually go in and define all of those relabel configs so that we can get access to the specific targets we want to scrape on a per job basis. Okay, so we've successfully gotten our Prometheus server set up to monitor our Kubernetes infrastructure. We've got all the endpoints set up. And so now I want to show you guys how to configure Prometheus when it's installed using the Prometheus operator to monitor an application that's running on your Kubernetes infrastructure. So I have a dummy Node.js application that we're going to use for demonstration purposes. And this is just making use of a library called Express, which is going to allow us to create an API. And it's a simple API where we can send requests to either /comments, /threads, or /replies, and it's going to just send some dummy data back. And a few other things to make note of when it comes to this application. It's going to be listening on port 3000. So when we set up our service, we want to make sure it forwards traffic to port 3000. And more importantly, I've set up Prometheus metrics to run on here. So you can access the Prometheus metrics at the following URL. So /swagger-stats/metrics. So that's the specific URL our Prometheus server should be scraping to get metrics data from our application. So what I'm going to do is I'm going to containerize this application. I'm going to push it up to Docker Hub, and then we're going to create all the Kubernetes manifests so that we can get our application successfully running on our Kubernetes infrastructure. Now, I already have a Docker file set up. So we've got a simple Docker file that's going to allow us to create an image from our application. And I'm going to go ahead and just do a Docker build now. So I'll do Docker build. I'm going to give it a specific tag. So this is going to be my Docker Hub username. And I'm going to call this Prometheus -demo. All right, make sure I do sudo. Okay, so we successfully built the image, and so now I'm going to do a Docker push for that same exact image. Okay, and so now we have successfully pushed our image up to Docker Hub. So now let's go ahead and set up our Kubernetes config so that we can actually deploy our application onto our Kubernetes cluster. Okay, so now let's create the Kubernetes manifest to deploy our application onto our cluster. So I'm going to create a new file. I'm just going to call this api-depl.yaml. So this is going to contain our deployment configurations as well as our service configuration. And what I'm going to do is I'm going to just copy and paste the configs in here. That way you don't have to watch me type it out. And we'll go over this line by line just to make sure that we're all on the same page. So here I've got a configuration where I have a deployment. I'm going to create a deployment here. I'm giving it some arbitrary name. I just called it API-deployment. And we've got a label. Under spec, we have replicas. So this is going to create 2 different instances of our app. And then we've got the selector match labels. This is going to be set to app API, and this needs to match up with the label over here. And then down below under the spec where we have the list of containers, I have 1 container. I just called it some arbitrary name of API. And then I have the image, which is the name that I used to push it up to Docker Hub. And then I have the container port, which is set to 3000, which is the port that the container actually listens on. So that's going to create the deployment. The next thing that we want to do is create our service, so we can handle communication. And you can use any kind of service that you want. It doesn't really matter. I'm just going to use a cluster IP. So technically it isn't accessible from the outside world, but that's okay. So here I've got a service. I'm giving it some arbitrary name, and I've got a couple of arbitrary labels. And then I have the type to be cluster IP. And then the selector, so this is going to select which pods it's going to work for. So it's going to be app API. So this has to match up with app API over here. And then for ports, I've got one port. I've called it web. It's going to be protocol TCP. It's going to forward port 3000 to the target port of the container of 3000. And once again, 3000 is going to be the port that the container is listening on, or the app is listening on. So those are all the configs I need. I'm going to deploy this. And I can do a kubectl apply -f, and then we can just call the api-depot.yaml file. And it looks like it created the deployment and the service, and we can just double check that real quick. So I'll do kubectl get service, and we can see our API service. And I'll do a kubectl get deployment, and we can see that it's up. There's one of two ready, so let's run this again. Maybe the second one will have come up by then. And we can see both are up and are working, so it looks like everything was successfully deployed. And so in the next video, we're going to take a look at how we can now set up Prometheus to scrape this application. So we got our application deployed onto Kubernetes. Now it's time to set up the Prometheus configuration so that it's aware of these new targets. And there's two different ways of doing this. And I don't want to say one way is the wrong way and one way is the right way. I would say that one way is the less ideal way and the other way is the more optimal way that the Prometheus operator would like you to configure it. So I'm going to show you the less preferred way first. We're not going to run through all of the steps. I just want to give you a high-level overview of what to change, and it's pretty straightforward. And then in the next video, we'll take a look at how we can make use of service monitors, which is the more ideal way of adding new targets to Prometheus. When we first covered Helm, I mentioned that we have the values file, which allows us to tweak the configuration of your Helm chart. And so what we want to do is we want to do Helm show values again. And this is going to be the name of the repo we have to pass in. So this is going to be Prometheus-community/cube Prometheus stack. And then we want to pipe this into a values.yaml file. So this will show you all of the different things that we can configure and modify. And in here, what we want to do is we want to search for something called additional scrape configs. So if you search for additional scrape, you'll see a section here called additional scrape configs, and it's going to go over what it means. So the documentation is actually pretty good. And so here, the additional scrape configs allow specifying additional Prometheus scrape configurations. So that's pretty much exactly what we're looking for. But it does give you a couple of disclaimers. It says that as scrape configs are appended, the user is responsible to make sure it's valid. It's not going to perform any kind of validation for you. And note that using this feature may expose the possibility to break upgrades of Prometheus. And so that's why I said this is the less ideal way of doing things. It'll work, but could potentially lead to some issues. So all you have to do is under this section right here, you can see additional scrape configs. All you have to do is just provide a list of jobs. And so this has an example job right here, and you'll notice the configs are exactly the same as a Prometheus configuration. It's just like configuring a job on your Prometheus server, no different. So you're just basically passing a list of new jobs. And so you could just uncomment this, remove this, and then provide all your jobs. So this is just one job in this case. And then after you have that, what we can do is do a Helm upgrade. So we would do Helm upgrade, and then the name of the release, which is Prometheus, then the name of the chart, and I'm just going to copy the name from the chart from right here. And then you want to do a -f, which is to pass in a file, and you want to pass in the values.yaml file. So this is going to contain the configuration, and then the upgrade is going to make any of the changes that are necessary from our previous deployment. And that should update the configuration, and then Prometheus should now be aware of the new targets. And like I said, this is the less ideal way. And so in the next video, we're going to cover how to use service monitors so that we can more declaratively apply new scrape configs for Prometheus. So now let's move on to seeing how we can add targets to the scrape list using the service monitor method. And so first, I want to talk about CRDs, or custom resource definitions. So the Prometheus operator that we have running comes with several custom resource definitions that provide a high-level abstraction for deploying Prometheus as well as configuring it. And we could take a look at all of the CRDs by running the command kubectl get CRD. And so there's several different CRDs. We could see at the top we've got one for alert manager config, we've got one for alert manager, but the two that we want to focus on are Prometheus. So this one is used to actually create a Prometheus instance, so you could provide various details regarding how you want it configured when you deploy it. And then specifically for this video, we have the service monitor CRD. So this is what we're going to use or create so that we can add additional targets for Prometheus to scrape. And a CRD is going to act like any other Prometheus object. We're going to configure it like any other Kubernetes resource. And I'm going to show you how easy it is to get a new set of targets added to your scrape list using the service monitors. So what is a service monitor? A service monitor defines a set of targets for Prometheus to monitor and scrape. And so what it does is it allows you to avoid having to touch the Prometheus configs directly, and it gives you a declarative Kubernetes syntax to define targets. So instead of modifying the Prometheus configs, what you're doing is actually creating Kubernetes resources that update the list of targets that you should be scraping. So it's going to look like you're creating regular Kubernetes resources. You won't really even be able to tell that you're touching the Prometheus configs. So we had previously deployed our app, and we deployed a deployment as well as a service. This is what our service looks like. Now, a service monitor is going to reference a service someplace in our application. So if we want to scrape our API that we created, we're going to have to reference the service that we created for our API. And we're going to create a service monitor. And if you take a look at it, it's basically like any other Kubernetes resource. Under kind, we just set it to service monitor. So it's our own custom resource that we define for our application. And there's a couple of things that I want to point out. First of all, we've got the name right here. This is just some arbitrary name. You can name it. Then we've got a couple of labels. These do matter, but we'll cover that in a bit. But really what we want to focus on is this endpoint section. So here we provide some information as to what is the scrape interval. So this is going to scrape a specific target every 30 seconds. And then the path. So, by default, it's going to be /metrics, but I told you our application is going to be running on /swagger-stats/metrics. So that's why you see that like this. Now, how do we actually get our service monitor to point to a specific service that our application is using? It's very simple. There's a couple of things. First of all, under the selector match labels, you're going to provide a label, which is going to be the label that you gave your service. So in this case, app service API happens to match up with app service API of our service. So it tells it what service we're referencing. And then we have to tell it which specific port that we're going to forward or which specific port we're going to scrape. And so in this case, we set port web, and that's going to match up with the name that we gave it here, which happens to be web. And so that's going to tell it to scrape port 3000 in this case because it's referencing this specific port. And then finally, by default, the job label for this target is going to be the name of the service. So it's going to default to API service. If you want to customize it, you can add this job label property. So the job label tells Prometheus that we should look for a label called job on the service. And then whatever value of that label is, that's going to be the name of our job. So in this case, we can see it's job here. So they match up here, job, and then the value here is going to be the job name. So the job name is going to be node-API. If I had changed this job label to be my label, then I would have to change job to be my label, and then whatever value here is going to be the new job name. And so that's all you have to do to configure a service monitor. You just specify the selector as well as the port, and then any other extra configuration when it comes to the interval as well as the path. And you can add an optional job label property as well. And that's going to let Prometheus know that it should scrape whichever target is behind the specific service. Now, there's one thing we have to add. So if I do kubectl get and then the name of the CRD for Prometheus, not the one for the service monitor, and we do -o YAML, we can see the configs. There's one property that I want to go over, and that's this service monitor selector. And so it provides a label here. In this case, it's release Prometheus. And so this label allows Prometheus to find service monitors in the cluster and register them so that it can start scraping the application the service monitor is pointing to. And so by default, Prometheus doesn't know which service monitors to look for, but if you give a service monitor this specific label, it knows to automatically add that to the target list. And so if we go to the configs of our service monitor, we need to make sure that same label is under the label section, and then Prometheus can dynamically add that. So that's the final requirement. Okay, so let's take a look at our CRD. So if I do kubectl get CRD, we should see a list of our CRDs. And there's two main CRDs we want to focus on. Like I said, the Prometheus one, as well as the service monitor one. So the Prometheus one, this is going to actually be responsible for creating the Prometheus instance, and the service monitors are there so that we can add extra targets and jobs. And we're going to do a kubectl get CRD, or get, and then we'll pass in the name of Prometheus. And I'm going to do -o YAML. Let's just make sure that we check to see what that selector label is. And so if I go up to service monitor selector, we could see that the match labels is set to release Prometheus. So when we create a service monitor, we want to make sure that this label is present. And by the way, the label that the Helm chart added, this is completely customizable by updating the values.yaml file. So if you ever wanted to change that, you can just modify that in the chart. So we have that. So what we're going to do is we're going to go to our api-depl.yaml, and we're going to go ahead and add our service monitor at the bottom. And I'm going to paste this in again. And it's going to be basically the same thing that we saw in the slides. So I've gave it a name of API service monitor. I've got the release Prometheus, so we need that so that Prometheus can dynamically discover this service monitor. I'm going to give this, the job label is going to be set to a value of job. So if I go up to my service, job is set to node API. So this is going to be the job label. Endpoints, this is going to have 30-second scrape interval with this following path. And it's going to point to a port of web. And if we can see, web is going to go to this specific one right here. And then match labels API-service or app API-service is going to match up with app API. And I realized this is just called API, so I'm just going to change this to API. So remember, they got a match. Okay, and that's all we need. So I'm going to pull up the terminal again. And I'm going to do a kubectl apply-f api-depl.yaml. And it's now successfully created a service monitor. And if you wanted to take a look at this, we could do kubectl get service monitor. And we could see all of the service monitors. And so there's some pre-existing ones that our Helm chart created. So that's why we have all of those targets that are already being scraped. We already have all of these defined. The Helm chart did it. This is going to be the one that we just created. Okay, so now that we have that configured, let's verify if Prometheus is actually scraping that. So I'm going to go to status, and I'm going to go to targets. And we could see that right at the top, we could see our API service-monitor. And so we can take a look, and we can see that there's two here, and that's because we have the replica count was set to 2 in our deployment, so it makes sense that there's 2 of them. And on top of that, we can take a look at the job. We can see it got properly set to node API. And if we go back to the main Prometheus, what we can do is just do a quick query. I'm going to do job equals node API, and let's just verify if we're actually getting metrics. And we can see that we are, in fact, successfully getting metrics. So we've now configured a new set of targets in our Prometheus instance using service monitors. And if you want to take a look at the final configs it actually generates on the Prometheus side, we can go there as well. So if we go to configuration and then we could search for API-service, we could see the final configs that were created, and that's going to be set right here. And so you could see that it looks like under Meta Kubernetes Service label app, we could see that the value is set to API, and it looks like we're going to keep that. And that looks like that's where it's actually matching the specific service in this service discovery, actually. And you can actually see the label here, Kubernetes endpoint port name. We can see that it's set to web. So all of the configs that we did in the service monitor, they're all lining up with the relabel configs for this specific scrape job. So we went over how we can add new targets using service monitors. Let's now take a look at how we can add rules. Now, to add rules, the Prometheus operator has a CRD called Prometheus rules, which handles registering new rules to a Prometheus instance. And so the way this is going to look like is it's going to be pretty similar to the service monitor, except the kind is going to be a Prometheus rule. And then when we go under spec, we just configure our rules like we normally would inside a prometheus.yaml file. So you can see we have a group section, and then we provide the name of the group, and then we specify all of the rules. So that's all it is. It's just a standard YAML file with a standard Kubernetes resource called Prometheus rules, and then you just specify all of your groups and rules like you normally would. Nothing else is really any different. One other thing to point out, if we do a kubectl get Prometheus, we can see that there is this rule selector property in the output. And so what this does is very similar to the service monitor selector, but this label allows Prometheus to find the Prometheus rules in the cluster and register them dynamically. So we will have to add that same specific label to our configs just to make sure that our Prometheus instance is able to find them. So let's add some rules to our deployment. And so I'm going to create a new file. I'm just going to call this rules.yaml. And I'm just going to paste the same configs that we had from the slides. And we'll just quickly go over them. So we've got one group called API, and then there's just one rule, which just checks to see if a node or instance is down. But most importantly, under the labels, we can see that we have our release Prometheus. So Prometheus should dynamically detect this and register this rule. And I'm going to do a kubectl apply-f rules.yaml. And I realized I forgot to save it. So now it's successfully created. And we can do a kubectl get Prometheus rule just to see if it got created. And we can see all of the pre-existing rules, but we want to find our API rule, and we can see that it was created 52 seconds ago. Okay, so now if we go to the Prometheus UI and we go to status and rules, let's take a look, and we can see our group API here, and we can see that we've got our rule successfully registered and in an OK state. And so that's all you have to do to register a rule. All you have to do is just create a new Prometheus rule object and then specify all of your rules, and that's all you have to do. Okay, so to add Alert Manager rules, the Prometheus operator has another CRD called Alert Manager Config, which handles registering new rules to the Alert Manager. And so this is an example config, and the Alert Manager config is also pretty straightforward. We have the kind set to Alert Manager config, and then if you take a look at the configuration under spec, this is just going to be standard Alert Manager config. So you've got your route, your group by, your group weight, and then you have your receiver here, and then your list of receivers. So it's actually no different than configuring a regular Alert Manager rule. Now, one thing to point out is that, once again, if we do a kubectl get alert managers and then take a look at the config, there's this one property called Alert Manager Config Selector. So just like we saw with Prometheus when we're setting up a rule or a service monitor, this label allows our Alert Manager to find Alert Manager config objects in the cluster and register them. But the important distinction here is that the Helm chart by default does not specify a label. So we don't actually have a label that we're supposed to specify on our Alert Manager config so that it can be registered. So we'll actually have to go into the chart and update this value so that we have a label that we could use. Now, when it comes to the standard alert manager.yaml configuration file that you have on a alert manager instance that isn't deployed on Kubernetes, it's going to be a little bit different than the alert manager config for the custom resource that's defined within Kubernetes using the Prometheus operator. And I want to highlight what some of the differences are because I got stuck on this for a little bit, and I want to make sure that you guys don't waste any unnecessary time trying to figure out what are the errors. So the first thing that I want to point out is when you're defining configurations like group by or group wait or group interval, you're going to see that on the standard alert manager.yaml configuration, it's going to make use of snake case. And snake case is whenever you have a property with multiple words like group wait or group interval, the two words are group and wait, you're going to separate them by a underscore. That's called snake case. Now, when we move to the alert manager config file, it's going to be a little bit different. Instead of using snake case, we're going to make use of camel case. And so with camel case, the two words are not separated by an underscore. Instead, they're combined together as one word, but you capitalize the first letter of the second word. So group wait is group and then capital W wait. And the same thing goes for all the other properties. And the only other difference that I want to point out is when you're setting up a matcher, let's say that you have a job label with the value of Kubernetes. When you move to the alert manager configuration on Kubernetes, the difference is going to be that instead of just specifying job Kubernetes as your label, you have to split it up so that you specify the name of the label